So I'm going to keep talking about trying to find limits as we do things analytically. So in this case, I want to try to focus on one of the really common methods of simplifying some of the more complex fraction ones. Specifically, it's called complex fractions and reciprocal. So the first one that I wanted to point out is one that you guys have done stuff like it before. It's when you have a number over x to some power. And it doesn't even really matter what power it is. It could be x to the first, or it could be x squared. It could be 3 over x to the fifth. It doesn't really matter. If you take the limit as it goes to positive infinity or even negative infinity, if it's just a number over x, it's going to go towards 0. And you can verify that pretty simply using graphs or even numerical methods, but that's an important one just to know, just to have in your head. And now I'm going to use that information to try to apply it to some of the more complex ones, okay? So here we go. I'm going to look at this first one. Now, with these complex fractions, especially headed toward infinity or negative infinity, one of the things you might have done when you were in Algebra 2 or even Advanced Algebra Trig or Pre-Calculus or any of those classes, you would have talked about things like horizontal asymptotes. And that's all well and good, and if you remember all those rules, great. But I'm going to show you a very simple method to help actually make your life a lot simpler. What I'm going to do is I'm going to look for the degree of the biggest, and I mean biggest, exponent. I'm going to go looking for the degree of that rational expression. So in this case, I've got x squared. That's the biggest on top, and I've got x squared on the bottom. So the biggest exponent I have is x squared. What I'm going to do is I'm going to literally divide everything by it. So watch what happens. X squared over x squared plus 3x over x squared minus 4 over x squared. That's the top. On the bottom, we're going to have 4 over x squared minus 2x over x squared plus 5 over x squared. Now I'm going to work on simplifying a little bit. So x squared over x squared just goes to 1. 3x over x squared, well, that's going to get rid of that x, and it's going to be plus 3 over x on top. I'm going to keep going. We've got 4 over x squared. That doesn't simplify at all. On the bottom, we've got 4 over, that should be a 4x squared. I wrote it incorrectly. The x squared is going to cancel. You're going to be left with 4. Then we're going to have x over x squared, so the x goes away, the squared goes away, so we're going to have 2 over x, and that 5 over x squared doesn't simplify. Now, if I try to look at each little part as it goes to infinity, well, like I said, if it's a number over x, that's going to go to 0. If I have a number over x squared, again, any exponent, it's going to go to 0. Again, x's on the bottom or x squared on the bottom, number divided by it, it's going to go to 0 and 0. So what happens when we get everything down? All of those things with x's on the bottom, they just disappear. So we're left with 1 over 4. Now let me repeat again. If you thought about horizontal asymptotes, you'd probably, or you should, get exactly that answer. But here's the thing. I didn't even have to think about that. I just had to divide by the biggest exponent. Now I'm going to apply the same thing on this last one just to see what happens. Now notice, on the top, I've got x to the first. That's not a very big degree. That's not a very big exponent. So let's look at the bottom. Now that's x cubed. That's bigger. So that's what I'm going to divide everything by is x cubed. So x over x cubed plus 4 over x cubed, that's the top, over x cubed divided by x cubed plus 8 over x cubed. Now, same process here. Just simplify. So x over x cubed turns into 1 over x squared. 4 over x cubed doesn't get simplified. It can't. All right, x cubed over x cubed is 1. 8 over x cubed, again, it can't be simplified, so I leave it alone. If it's a number over x squared, x cubed, or just plain x, if it's a number over x to any exponent, it goes to 0. So that's 0. That's 0. That's 0. They're all 0 except for that one lonesome 1. So what I'm left with is 0 over 1. That's just 0. So the limit as x goes to infinity of that function is just 0. Again, could have done it with horizontal asymptotes, but why remember extra information if I can use this process to simplify it for me?